Uh, this is one optional scenario. Let's say if the array which we are given is shorted. In such case, we can implement one more method, which is of ON in nature, because we will be using just one loop. What exactly this solution is? I will assign. I will take two things. First, one variable would be low, other would be high. For low, I'll assign the lowest index, which is 0. For high, I would assign the highest index, which is 4. And I'll just run a loop while low is less than high. I'll check my first pointer is here, second pointer is here. I'll check if 1 plus 5 is equal to target or not. If they are equal to target, I'll simply return low, comma high, the indices. And let's say if it's greater than our target, what I'll do, I'll just decrement my high. Why I will decrement my high? Let's see one example. Since my array is shorted, Okay, shorted means what? Since it is shorted, that means smaller elements are to the left and large elements to the right. Right. Okay. So what will happen if I am adding two elements, ai plus a of j, and it is coming greater than the target. Let's say my target here for this example is 7. Okay. So initially my first pointer is as 2 and j is at 7. I will add 2 and 7. Output would be 9, which is greater than target. Now see here, what is exactly is happening. I'm getting a number greater than my target because my target is 7 and I am getting 9. Okay, so I need to decrement my iteration in such a way that it would produce smaller elements. What elements? Smaller. Now, for smaller elements, since the array is shorted, I will get a smaller element to the left only because I can increment I to the right only. This is the only part. And for j, I am coming to the left because I cannot go right from my j, because if I go here, there are no elements and it would be index out of range. So in case of when sum is coming out greater than the target, I will simply decrement j by 1. Okay, and now my j would be here, and now I will check if 2 plus 5 is coming to my target. In this case, it is coming out to be true. So I will return the index of this element and this element, which is 0, 2. Let's consider the second situation where my sum is less than target. If my sum is less than target, let's say instead of 7, I'm assuming my target to be let's say my target to be, let me erase this first. Hmm. Something greater than 3, 7, 3, 10. Okay, let's say my target is now 10, 2, 3, 5, 7. My array A is 2, 3, 5, 7, and target is 10. So in my first iteration, my I would be here at 2, I is at 2, and j is at 7. I will add 7 plus 2, which would come out to be 9. It is less than my target, less than 10, right? Now I need to do something so that I would increase the sum. Since I am at j, I cannot go beyond j, because for j we would only move left, and for I we will move right. So in case we are getting a sum less than target, in such cases we would be incrementing I by 1. So this would be the complete pseudocode when my Aops law plus I is equal to target. We would be simply returning the indices. If it's less than target, we would be incrementing our low indices. Low indices means we would be moving our I pointer to the right. Else, we would be decrementing our J pointer. This is also for when solution space complexity is constant, because we are not using any extra spaces. But the only condition is array should be shortened. You can implement the solution for that and check. We are not going to implement this solution because our problem was in general, but this is also one of the approach where you can short the array and solve this problem in this way.